Welcome. In this video, we're going to lay the foundation for creating behaviors and actions by writing instructions to do something. We call those methods, aka functions. So what is a method and why use them? Methods are instructions to do something, like a recipe. The reason we use them is to group code together for organization, flexibility, and the most important, reusability. Oftentimes, people might say a method is like the recipe, instructions to make something, then the variables would be the ingredients for the recipe. I like to think of them as a servant that, when called, will do the assigned task. To create a method, we'll use this format and place your code for the task inside the curly braces. Then you can call the method inside the script and it will complete those tasks. In Unity, we need to distinguish between two types of methods. One is methods from Unity, the Unity engine, and two is the custom methods that we write. The main difference is custom methods need to be called to be executed. In our project window, we're going to right-click, create C# script, name it methods. We're then in the hierarchy, we want to actually put this script in our game. So we're going to right-click in the hierarchy, create an empty, and call it methods manager. Then in the inspector window, go to the three dots and, as good practice, reset the transforms. In our project window, we'll go ahead and double click the methods script. Here, you'll notice we're given two template methods in our script to help get us started. We can go ahead and delete these comments real quick and save as we go, Control S. So Unity has some helpful documentation. If we click on Start, we can go up to our Help menu and then Unity API Reference. There are two shortcuts that you have to use in order to open this shortcut, or we could just do it through the Help menu and just open this up. Now, if your Visual Studio does not have this, most likely your project also will say Solution 1 instead of the name of your project. So what you would need to do is come back into Unity. You're going to go up to Edit, Preferences, External Tools, and then your external script editor. It should be set to Microsoft Visual Studio, unless of course you're using some kind of different editor. Once you do that, you'll have to close out of Visual Studio and double click the methods script and reopen that back up. So let's go ahead and do that. Help, Unity API Reference, click that, and it pulls up all references for start. In this case, start and update are mono behaviors. If we hover our mouse over it, it's not going to give you as much information. It gives you a little bit, but then also mono behavior up here will point to the Unity engine. So we have to understand a little bit about these two methods are mono behaviors that come from the Unity engine, to keep it simple. What we're looking for is a start related to mono behaviors. So right here, you're going to see mono behavior start. Start is called on the frame when a script is enabled just before any update methods are called the first time. So we can click this to get more information, but also as you read this information, it's going to give you some hints. So one of these, it says just before any of the update methods, plural. So there are a bunch of different update methods. So we click that and it loads our monobehavior.start, what we read already, and it gives us some additional information, which is really helpful to kind of read through this. It also has a sample script that you could write up and test out, and this will also give you more practice and help you to be a stronger coder and understand methods. Now, to look at more mono behaviors, we can click mono behavior in front, and that's going to take us to all the information about mono behaviors. So your most popular ones are going to be awake, start, update, fixed update, late update, but also invoke, start coroutine, your on collisions, on mouse down, and your on triggers, both for 2D and 3D games. We'll talk more about those at another time. So the two other mono behaviors we want to take a look at is going to be update and fixed update. Update is called every frame. This is going to be important to note because if you have a really fast computer that's running at 150 frames per second, and then you have another computer that's a slower computer that's only running at 20 FPS, right, frames per second, right, you're going to have an issue with gameplay because the game might run normal on the fast computer, or maybe even faster than it should, and on the slow computer, it's going to run slow. And that provides some issues. Now, that's if we had everything written in this update method, which we'll not. But important to note that this is called every frame. Some examples and some information here that you can take a look at. For fixed update, it lets us know, and we'll read through this, and there's a lot of information here, but it's a couple things, right? This one is frame rate independent, and it's for physics calculations. You'll see this again, and you'll see if we read through this that it's called every 0.02 seconds, which is going to be 50 calls per second, and that's the default time between calls. So some very useful information. Another way to pull up the help documentation is you could just do a search in your browser for Unity API start, and you'll see usually the first one that pops up is the monobehavior.start, because that's going to be the most common, most popular thing that people are looking for. So we can click that, and that will pull up the link for the manual for that information. Now, let's go back to our script. So what we're going to do is let's take a look at a breakdown of the format and some of the rules for writing a method that'll help you for troubleshooting in the future. So we have the accessor, return type, and the name of method, parentheses, and then in our curly braces, you'll have the instructions, and any statements will have a semicolon. So you won't always have to list the accessor, but the return type and the name of the method are required. You also have to have parentheses, even if there's nothing there. You have to have the two curly braces, that is the beginning of that method and the end of that method, you could say, and then the instructions that go in the middle. So kind of an example here would be update health. If we were wanting another script to use this method, then in this script, we would want it to be public, so that way another script could access it, right? Void just means there's no return type, there's no data we're returning, and then we've named the method and then everything else. So again, access, return type, name and method, and the parameters, which may be empty if you don't have any specific placeholders, arguments, or parameters. So back in our method script, so our start, we know this, runs one time when the script is enabled. We know update runs every frame. And the main reason that we would want to use update is I use it for input checks. So checking for input. It's kind of shorter. Checking for input. And then we're going to add another method in here. So I'm going to space down. We like to put a gap, keep it organized. As we'll do void fixed update. And you notice if I tab over, it adds in private. We don't necessarily need that because the default is it's private already, even if I don't say private, just like variables. Same thing. Now, of course, fixed update runs 0.02 seconds or 50 calls per second. So that's running at a fixed time. And the main thing to note for this is where we want to put our physics calculations. So now not everybody follows that, say on YouTube or other places, but that is generally what is advised to do that. Now we can test these out by doing a debug.log or a print. And yeah, they are the same thing, but I encourage students to do debug.log because it gets you used to using debug, and we're going to use debug for troubleshooting because it does have official debugging tools. But for this, we're just using the .log, which logs a message just like print logs a message. But we do debug.log, and we're going to put a message. Now, a message can be where we can put a variable in here, but we can also do a string message. So just like you have a string variable, we're going to do a string message. And all this means is we got to follow the same rules. So when you're writing a string, you have to have quotations. And we could simply say running start. I could type whatever I want in here. But when I save this, go back into Unity. And when I press play, I would get a message here if my script is running. It's like maybe I forgot to put it on my game object. So let me do that again. I created an empty, right? We reset the transforms. I'm going to drag this onto the add component so we get our methods script on there. Now it's in the game, and we go to our console and we see running start runs one time because we started the game. This object had the script, so the script was started as well, enabled. There we go. Now we could do the same thing for the other ones. We'll do running update. And we'll also do running fixed. Oh yeah. I mean, you could type in whatever, but we're testing it, so just so you get the point. And you'll see update is going to depend on how fast your computer is. So back in Unity, if we have collapse off, this is going to keep running and running and running and running and running. It's kind of hard to see. And you see there's over 1,000 messages. So we're going to collapse this. And I'm going to reset this back to default. But you can see that we have running fixed is running less because it's at a fixed time rate versus running update on this computer that's maybe fairly fast, I don't know, is running a lot, right? It's just printing this message over and over and over again. So we can turn off play. You can clear these out if you want. You don't have to. If we do play again, it's just going to clear them out anyway. And we'll go back to our script. All right, so let's get to it. The ingredients. Let's start cooking this up. I'm just going to clean this up and delete this space. And up here at the top, we're going to start adding in our integers. So we'll have number 1, and we'll set that to equal 3. And we'll have integer number 2, and we'll set that to 7. Great numbers, right? And let's go ahead and, serialize this, because actually, let me delete this. You remember from our variable section, right? This is 2 whole numbers. They're integers. And if we save this and go back into our Unity project, then it will update. Oh, it won't update. It doesn't show because we haven't done serialized fields, so it's not going to be anything there. So what we want to do is, even though it's private, we don't want other scripts to change it right now, so there's no reason to make it public. But we do want to see it in the inspector. So that's why we would do serialized field. Just a quick reminder on that. But I'm going to copy and paste this, or just type it up again. And you can put spaces there, no spaces, but there we have it. So we serialize these, we save this, and we could just even pull this down. And there we go. There we go. Number 1 is 3, number 2 is 7. Now, if we change this in the inspector, it will override what's in our script. So I'm going to leave it exactly the same and not mess with it. That's just so we can see it. Now what we're going to do, we got 2 numbers. We're going to create a method to add these together. So right now, we're not going to be returning anything. So that means it would just be void. And if we're adding these 2 numbers, it would make sense to name the method add 2 numbers. Parentheses. Voila. So the deal here is you want to name your method an action based on what you're doing, so it's very clear, or as clear as possible. And we're going to go ahead and do the numbers. Now, if we just type in number 1 plus number 2, semicolon. So, and it gives us a warning. It says, hey, look, you can only do an assignment. That means, right, equals. Call something, call another method. Increment something, a variable. Increment, like, you know, adding +1, or decrement, -1, right? Await something, or another expression, making a statement. So this is an incorrect statement. We can't do that. So that's fine. We're going to add these 2 numbers together, and what would make sense is we're going to assign this to another variable. but we haven't created a variable for it. Now, we could create a variable here and say answer, but this would be a local variable. So that means I can't use it anywhere else in the script because it's only going to be in this method. So this is a local variable, okay? So if you wanted to make a note of that, since I don't think I had that in the variables video, but you could do int. We could just say test variable, and you could say, whoops, this is a local variable. And you could also make a note that this cannot be accessed anywhere else. So, and it's kind of give us a warning. We could just go ahead and set it to something like 1. It's still going to let us know, hey, this variable is declared but never used. So it doesn't really matter. But either way, maybe I'll just comment that whole thing out just so we know. But anyway, integer answer. So what I actually want to do is instead, I'm going to cut this out and I'm going to put it at the top, but I'm going to serialize it first so that way we can see it. So we'll do int answer, and we're just declaring it. We know there's going to be an answer, but if we change these numbers, the answer is going to be different, right? So we don't want to say the answer is 10, because what if I change 3 and 7? So you may still have questions. It's okay, just stick with me on this. So here, all I have to do is say, hey, remember that variable? It was called answer. Well, answer is now going to be assigned number 1 plus number 2. So now what we want to do is we could print that answer, but we've kind of already covered that, right? We could print the variable answer and we're good. So let's do something else. Instead, we're going to do another method called void print total. And now we're kind of getting into some deeper, heavier stuff. We're getting into some good nutrient-rich methods here. So that is, we're going to print total. For this, we're going to do like an equation. We want to be able to reuse this method and say, hey, anytime I want to do print total, I could run this method and print, and I can call this anytime. So in that case, in the parameters, or you could call it an argument, we're going to say it has to have an int number, with the method. And then in our instructions, we're simply, you could do debug.log, right? Or a print. We'll do debug again. And this would be whatever the number is that comes in here. That's what we're printing. There we go. So that means even in our, well, let's go over this first. Jumping ahead here, I'm just getting a little too excited. Woo! Okay, so we have a method here, add 2 numbers, and we're telling it, take these specific 2 numbers and add them together. That's great and all, but it's not actually running. This would be just like if I said, hey, I want you to write an essay on ... and it needs to be 2 pages, double-spaced, 12-point font, blah, blah, blah. You get the idea, right? But if I'm just like, well, here's how to write the essay and what I would want, but if I never say, hey, I need this essay written now, you're going to turn this in, and you might win ... fill in the blank, or fill in the dots. That doesn't make sense. Anyway, so this is just the instructions, okay? I need to actually call this method. So what I can do here is with the print total, I can call that up here and I could say print, let's see, it was print total. And then what do I want to print? Let's say I could do number 2 plus number 2. This could be a really long line of code, but I could also say, hey, total 2 is, and then have another plus there. In this case, this is not going to work because I'm not using the print function, and you see I can only be an integer whole number. So I could do number 2 plus number 2, and it'll add those together first. That becomes our number, and then it logs that number. So that will work. But another way, if I wanted to print this answer, I can simply do my debug.log, and I could print the answer. So for this method, it would get these two numbers, specific, assign it to the variable, and then log that variable. Okay. Now with this, I might want to change this to be like add two numbers and print, or and log. Some people might not, print might be better for now, but to be clear. But anyway, we can call it that. Now to call this though, because add two numbers isn't running, we do have print total. So I would challenge you to see if you could go ahead and pause the video, and how do you call or tell it to execute add two numbers in log? So hopefully you took a test run at that, maybe a minute or two. So what we're going to do is call the method by name, parentheses. There is no parameters or arguments required for this. So all we have to do is put a semicolon, and it basically says, go to this method and run it, and move on. So those are some of the foundational basics for methods. Okay, check it out. We're going to talk about what I call super methods. That's like methods inside of methods, or a method that's then assigned to a variable that's then put into another method. Dun, 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 dun. In your project window, right-click, create a C# script, and we're going to name this super methods. Then go ahead and double-click that. To start this off, we're going to need a few variables. So we'll just use integer apples. So let's go ahead and type these out. Okay, so once you have those typed up, let's create our first method. Instead of update, we're going to call this one display result. Now, of course, we're not doing anything with UI, but this is where I would probably put something to display it in UI. But for right now, we'll do a debug.log, and we'll say the complete total is, and then we're going to add whatever the total will be to that. So the first thing that we want to do is we're going to have this argument, or these parameters. You could say this placeholder or requirement. We're going to say, if you're going to call display result, when you call it, you're going to have to put in a number. So we're going to say it's got to be a whole number. We're just going to call it total for right now. And then right here, we'll put total. So the way this works is in start, we could say display result. Whoops. And then we have to include what is this integer here that will then print. Okay. Because it'll give us an error, and it'll say, whoa, 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 you must put, this argument says you have to have an integer here. So that means I could say even pecans plus walnuts, and it'll add those two together, right? Those both integers, it'll add those together, and then it will log those to the console with this string message. The complete total is, and it would be 20, right? So you could playtest that, save it and playtest if you want to see that result. Now we do need to put the super methods in our game first, or else it's not going to work. So let's actually save that and do that. So we'll run back into Unity, and what we can do is our methods manager. If you only want to see one at a time, what we could do is just click the three dots and remove our methods script, and then we're going to drag in our super methods. Right, that way when we press play, we'll see that message in the console. So you can do that now if you want to check that. So that is one way of doing that. I could also just do pecans, which 9, it's going to say the complete total is 9. It's going to log that in the console. Now that's great. We just got that started. Now we're going to do something very similar again, but we're going to change it up. Let's say I gave everybody a piece of paper in a class, and I said, here's the instructions to make an airplane. Now I want you to make that airplane now, but bring me the airplanes. Because then I'm going to throw all the airplanes and see which one might go the farthest, and I'm going to record all the data. So the instructions are how to make an airplane, but then I'm also saying when you make your airplane, then you have to return it back to me. So right now, the only thing that we've done is instructions. So we are going to add on to that we are going to have the return type where we're going to return the number, of which then we're going to use that number for something else. So let's go ahead and do that so you can see that in action. So in this case, we're not going to have a void method because we are going to return a number. So it's a whole number, so we'll do int add two numbers, kind of like before, but this is going to be different. So we'll do add num1 integer num2. And then in our curly braces, we'll do num1 plus num2. Of course, again, we can't just add these two together because it lets you know here, listen, if you're going to write instructions here, you need to be assigning something, calling something else, incrementing or decrement or await or some other expression for this statement. So we can't just write a statement like this. But what we can do to make this a statement is we could assign this to a variable. In this case, I could call this result. So when we add num1 to num2, that'll be our result. And then our method is going to return whole numbers. But what I have to do here is I have to do return. And what am I returning? Well, in this case, after I add these two together and I assign them to this variable, I'm going to return that variable. So you could call these like placeholders. Think of algebra, right? We're just filling in for what the variables are and solving, essentially. So if we run add two numbers, let's go ahead and do that. Let's do that. So right here, we're just going to go ahead and get rid of this for right now. So in start, because add two numbers isn't running. If you remember, these are custom methods. So as of me deleting this now, add two numbers is not running and display result is not running. Even if I saved and play tested the game, they're not running. So what I want to do in start is I'm going to say, okay, add two numbers. What are the two numbers that we're going to add? We'll say apples and pecans. So if I say run this, right, it's going to take apples is 3, pecans is 9, and we get 12, right? So this is going to end up returning 12. So here's what we can do with that. We're going to assign this to a variable and then use the variable in the other method. So this is where I think it gets really cool. So int answer 1. So we're creating a local variable. We're not going to use this variable anywhere else. So because this variable is in start, we can't use it anywhere else unless if it's inside of start. So we add two numbers, apples and pecans. This will equal 12, and it's going to assign that to answer 1. So answer 1 is 12. So then if we say, okay, well, display the result, what are we displaying? Answer 1, right? So it runs this, it gets 12, it assigns it to answer 1, and then we could print it. That's a nice clean way of writing it. And then we're also going to do that again. So we could do another one. So we'll call this answer 2. And we'll do, okay, let's add another 2 numbers. Okay, maybe I want to do oranges and walnuts. So it's going to add those together. And then we'll run display result. And we'll display answer number 2. So we're running this method to calculate for us the count for this, which then we're displaying it, logging it to the console. And then we're doing the same thing again for oranges and walnuts. So save that and jump back into Unity so you can play test and check that out for yourself. So that gets me pumped up. That's pretty deep into methods if this is the first time for doing this. So don't worry if you don't fully understand this as you write other methods. I've got several other videos with destroying objects or changing the color, our basic movements for translate and rotate. And so as you write methods and follow along, you're going to get more comfortable and it's going to sink in and make more sense. And you're going to increase your mastery for each of the parts of writing C# code.